Hello, sir. I'm Junaray Daquilos, and I am third year BS Civil Engineering Section A at University of Southern Mindanao main campus. And this is my assignment number 1 at Principles of Design. Problem number 2.1. A column in the upper story of a building is subjected to a compressive load from the following source. Dead load equals to 30.88 kips. Occupancy load, live load is equals to 1.7 kips. Roof live load equals to 18.7 kips. And snow load equals to 19.7 kips. Letter A. If a load resistance factor design is used, determine the factored load required strength to be used in the design of the column, which AISC load combination controls. Given dead load equals to 30.8 kips, live load equals to 1.7 kips, roof load equals to 18.7 kips, and snow load equals to 19.7 kips. Uh, and solution number 1, combination number 1, 1.4 dead load equals to 1.4 times 30.8 equals 43.4 kips. Combination number 2, 1.2 dead loads plus 1.6 live load plus 0.5 snow load equals 1.2 times 30.8 plus 1.6 times 1.7 plus 0.5 times 19.7 equals 49.53 kips. At combination number 3, 1.2 dead load plus 1.6 snow load plus 0.5 live load is equals to 1.2 times 30.8 plus 1.6 times 19.7 plus 0.5 times 1.7 is equals to 69.33 kips. Therefore, combination 3 controls required strength PU equals 69.3 kips. Next, what is the required design strength of the column? Since PU less than or equal theta C Pn, so theta P theta CPN is equals to 69.33 kips. Next, letter C. What is required nominal strength of the column for a resistance factor of 0.90? Pn is equals to theta C Pn over theta C equals 69.33 divided by 0.90 is Pn equals to, or nominal strength equals to 77.03 kips. Letter D. If allowable strength design is used, determine the required load capacity, required strength to be used in the design of column which AC load combination controls. Combination 1. D dead load equals 30.8 kips. At combination 2, dead load plus live load equals 30. 30, 30 is 30 plus 8, 30.8 plus 1.7 is equals to 32.5 kips. Combination 3. D plus LR or S or R equals to 30.8 plus 19.7 equals 50.5 kips. At combination number 4, dead load or D plus 0.75 live load plus 0.75 times I or LR or roof load or snow load or required strength is equals to 30.8 plus 0.75 times 1.7 plus 0.75 times 19.7. Then it is equals to 50.5 kips. Therefore, combination 3 controls PA required strength equals to 50.5 kips. Letter E. What is the required nominal strength of the column for a safety factor omega of 1.67? PA or required nominal strength less than or equal to Pn over omega. Pn is equals to omega Pa equals 1.67 times 50.5. Pn is equals to 84.3 kips. Next, problem number 2. A column is subjected to the following loads. Dead load equals to 26 kips. Occupancy live load equals to 15 kips. Roof live load equals to 5 kips. Snow load equals to 8 kips. Rain load equals to 5 kips. And wind load is equals to 8 kips. All loads are compression except for the wind load, which can be either tension or compression. Letter A. If load and resistance factor design is used, determine the factored load required strength to be used in the design of a column, which AISC load combination controls. Given dead load equals to 26 kips, live load is equals to 15 kips, roof load equals to 5 kips, snow load equals to 8 kips, rain loads equals to 5 kips, and wind load equals to 8 kips. Solution. Combination number 1. 1.4 dead load is equals to 1.4 times 26 equals 36.4 kips. Combination number 2. 1.2 dead load plus 1.6 live load plus 0.5 live ang roof load or snow load or rain load. Dahil snow load ang pinakamataas, si snow load ang gamitin. Equals 1.2 times 26 plus 1.6 times 15 plus 0.5 times 8 is equals to 59.2 kips. Combination number 3. 1.2 dead load plus 1.6 roof load or snow load or rain load plus 0.5 left road left ay live load or wind load is equals to 1.2 plus 26 plus 1.6. So, snow load man ang pinakamataas, then times 8 plus 0.5 times 15 live, dahil live load ang pinakamataas equals to 51.5 kips. Combination number 4. 1.2 dead load plus 1.0 wind load plus live load plus 0.5 roof load or snow load or rain load is equals to 1.2 times 26 plus 0.1 times 8, dahil Snow load ang pinakamataas. Then, plus 0.5 times 8 plus 0.5 times 15 is equals to 50.7 kips. Combination 2 is 2 controls. PU is equals to 59.2 kips. Next, B. What is the required design strength of the column? Since PU is less than or equal to theta C Pn, so theta CPn is equals to 59.2 kips. Next, letter C. What is the required nominal strength of the column for a resistance factor of 0.90? Pn is equals to theta C Pn over theta C is equals to 59.2 divided by 0.90. Pn is equals to 65.78 kips. Next, D. If allowable strength design is used, determine the required load capacity, required strength, to be used in the design of column, which AISC load combination controls. Combination number 1. Dead load is equals to 26.6 kips. Combination number 2. Dead load plus live load is equals to 26.6 plus 15 kips, 15 equals 41.6 kips. Combination number 3. Dead load plus roof load or snow load or rain load is equals to 26.8 dahil snow load ang pinakamataas equals 34.6 skips. Combination number 4. D or dead load plus 0.75 live load plus 0.75 roof load or snow load or rain load road is equals to 26.6 plus 0.75 times 15 plus 0.75 times 8 dahil snow load ang pinakamataas and it is equals to 43.25 kips at combination number 5 dead load plus 0.6 wind load or 0.7 E is equals to 26.6 plus 0.6 times 8 equals 34 kips. Combination 6A. D plus 0.75 live load plus 0.75 times 0.6 wind load plus 0.75 roof load or snow load or rain load is equals to 30.8 plus 0.75 times 15 plus 0.75 times 6 times 8 plus 0.75 times 8 snow load ang pinili dahil siya ang pinakamataas. Then it is equals to 46.85 85 kips. Therefore, combination 6A controls PA is equals to 46.8 kips. Next, what is the required nominal strength of the column for a safety factor omega of 1.67? PA less than or equal to PN over omega. PN is equals to omega PA is equals to 1.67 times 46.85. PN is equals to 78.2 kips. Then next, problem number 2.3. The loads on a roof beam consists of a dead load of 0.2 kips per feet, a roof live load of 0.13 kips per feet, and a snow load of 0.14 kips per feet. Next, Letter A. If load and resistance factor design is used, determine the factored load required strength to be used in the design of this beam, which AISC load combination controls. Given dead load is equals to 0.2 kips per feet, roof load is equals to 0.13 kips per feet, snow load is equals to 0.14 kips per feet. Then solution. Combination number 1. 1.4D or dead load is equals to 1.4 times 0.2. Then 0 it is equals to 0.28 kips per feet. And at combination number 2, 1.2D plus 1.6 L or live load plus 0.5 roof load or snow load or rain load is equals to 1.2 times 2 plus 1.6 times 0 plus 0.5 times 0.14. So, dahil ang pinakamataas is no load, then yun ang gamitin natin. And it is equals to 0.31 kips per feet. And at combination number 3, 1.2 dead load plus 1.6 roof load or snow load or rain load plus 0.5 live load or wind load is equals to 1.2 times 0.2 plus 1.6 times 0.4, then kasi snow load ang pinakataas, then ito ang gamitin natin plus 0.5 times 0 dahil wala tayong live load or kag-wind load. It is equals to 0.46 0.4664 kips per feet. And therefore, combination 3 controls PU is equals to 0.46.3 kips per feet. Next, letter B. If allowable strength design is used, determine the required load capacity required strength to be used in the design of the column, which AISC load combination controls. At combination number 1, dead load is equals to 0.2 kips per feet. Combination number 2 is equals to dead load plus live load. 0.2 plus 0 is equals to 0.2 kips per feet. Combination number 3, dead load plus roof load or snow load or rain load is equals to 0.2 plus 0.14. Since snow load ang pinakamataas, yun ang gamitin natin. It is 0.14. Then, it is equals to 0.34 kips per feet. Therefore, combination 3 controls PA is equals to 0.34 kips per feet. Next, problem number 2.3. Beams will be designed for a roof and floor system of an office building. The load for this system are as follows. Roof. Dead load is equals to 30 PSF. Roof load. Roof live load is equals to 20 PSF. Snow load is equals to 21 PSF. And rain load loading consistent of 4 inches of water. Floor. Dead load is equals to 62 PSF and occupancy live load is equals to 80 PSF. Next, letter A. For each of these system, determine the required factored load capacity or LRFD, which load combination controls. Given from roof, D is equals to 30 PSF, LR or roof load is equals to 20 PSF, snow load is equals to 21 PSF and R is equals to 14 over 12 times 62.4 equals to 20.8 PSF. Solution. In combination number 1, 1.4 dead load is equals to 1.4 times 30 equals 42.42 PSF. In combination number 2, 1.2 dead load plus 1.6 live load plus 0.5 roof load or snow load or required rain load is equals to 1.2 times 30 plus 1.6 times 0 plus 0.5 times 0.14. Then it is equals to 0.31 kips per feet. Combination number 3. 1.2 dead load plus 1.6 roof load or snow load or rain load plus 0.5 live load or wind load is equals to 1.2 times 30 plus 1.6 times 21 plus 0.4 times 0 dahil wala man sang live load and wind load, and it is equals to 69.6 PSF. Therefore, combination 3 controls PU is equals to 69.6 PSF. Next, for given sang floor, dead load is equals to 62 PSF and live load is equals to 80 PSF. At solution, at combination number 1, 1.4 dead load is equals to 1.4 times 62. It is equals to 86.8 PSF. And at combination number 2, 1.2 dead load plus 1.6 live load plus 0.5 roof load or snow load or rain load. It is equals to 1.2 times 62 plus 1.6 times 62 plus 0.5 times 0 dahil wala ta value sang roof load and etc. Therefore, the answer is 202 PSF. Combination 2 controls PU it equals to 202 PSF. Next, letter B. Each of these system determined as required ASD load capacity, which load combination controls. Combination number 1 it is equals to the dead load is 62 PSF. At combination number 2, the or dead load plus live load it is equals to 62 plus 80 is equals to 142 PSF. Therefore, combination 2 controls PA it equals to 142 PSF. Next, problem number 2.5. Structural steel building frequently are designed with diagonal bracing system to resist lateral loads, horizontal force resulting from wind or earthquake loads. A. A certain bracing system is subjected to the following loads. Dead load is equals to 13.3 kips. Occupancy live loads is equals to 6.9 kips. Roof live loads is equals to 1.3 kips. Snow load is equals to 1.3 kips. Wind load is equals to 150.6 kips and earthquake loads is equals to 161.1 kips. Next, letter A. Determine the required factored load capacity for LRFD, which load combination controls. Given, dead load is equals to 13.3 kips. Live load is equals to 6.9 kips. Roof load is equals to 1.3 kips. Snow load is equals to 1.3 kips. Wind load is equals to 150.6 kips. And earthquake loads is equals to 161.1 kips. Then solution. Combination number 1. 1.4 dead loads is equals to 1.4 times 13.3 equals 18.62 kips. Combination number 2, 1.2 dead load plus 1.6 live load plus 0.5 LR or roof load or snow load or rain load. It is equals to 1.2 times 13.3 plus 1.6 times 9.6.9 plus 0.5 times 1.3. Then ang 1.3 is nanggaling sa roof load or snow load. Then ang answer is 27.65 kips. Combination number 3, 1.2 dead load plus 1.6 roof load or snow load or rain load plus 0.5 live load or wind load equals 1.2 times 13.3 plus 1.6 times 1.3 plus 0.5 times 150.6. Then, ang 150.6 is, yan ang wind load. It is equals to 93.34 kips. Combination number 4. 1.2 dead load plus 1.0 wind load plus 0.5 live load plus 0.5 lift roof load is equals to 1.2 times 13.3 plus 1.0 times 150 times 6 plus 0.5 times 6.9 plus 0.5 times 1.3. It is equals to 170 kips, 0.7 kips. Combination number 5. 1.2 dead load plus 1.0 E plus 0.5 live load plus 0.2 rain load. It is equals to 1.3 ay 1.2 times 13.3 plus 1.0 times 1.61 K plus it is equals to 180 kips. Therefore, combination 5 controls PU, it is equals to 180 kips. Next, letter B. Determine the required ASD load capacity. Which load combination controls? Combination number 1, dead load is equals to 13.3 kips. Combination number 2 is dead load plus live load. 13.3 plus 69 is equals to 20.2 kips. Combination number 3, D plus LR or S or R. It is 13.3 plus 1.3. Then it is equals to 14.6 kips. Combination number 4, D plus 0.75 L or live load plus 0.75 roof load or snow load or rain load equals 13.3 plus 0.75 times 6.9 plus 0.75 times 1.3. It is equals to 19.45 kips. Therefore, combination 5, it is equals controls PA equals to 126.1 kips. And that's all for today and thank you, sir.